Torsional frequency of hollow shaft. So we'll see now how the torsional frequency is calculated for the hollow shaft when multiple discs are attached to the shaft. This is a steps for Holzer methods. So assume angular frequency omega radian per second in such a way that the torque at the last disc should be 0 for the frayed shaft, and that assumed omega is the natural frequency. So these are the steps. First of all, assume disk 1, assume theta 1 is a 1, theta 1a is angular twist at disk 1 is 1, and the torque T1 is equal to I1 omega square theta 1a. At disk 2, theta 2a is equal to theta 1a minus T1 upon K1, and torque T2 is equal to T1 plus I2 omega square theta 2a. And this way we keep on calculating angle of twist and torque at different uh, disks. When T n is become 0 for the frayed shaft, then assumed angular frequency is the torsion natural frequency, and similar procedures to be followed up for higher natural frequency by assuming higher angular speed omega. Mode shape of the torsion natural frequency is plotted on length of the shaft versus angular displacement. Now understanding with an example for how torsion natural frequencies for the hollow shaft is calculated. Assuming 3-disc hollow shaft. So refer picture 1. A hollow shaft is having 3 number of discs, each having disc mass 500 kg. Outer diameter of disc is 0.2 meter. Outer inner diameter of shaft 0.06 and 0.04 meter respectively for entire length. Length between the shaft each section is 0.4 meter, and Young modulus of elasticity is 2.1 into 10 to the power 11 Pascal, and Poisson ratio is 0.03. Calculate the torsion natural frequency and mode shape. Mass moment of inertia of discs, since all having same mass and diameter, so you can calculate I1 is equal to I2 is equal to I3, which is coming 2.5 kg per meter square, and shaft stiffness is calculated, which is coming 2.6 into 10 to the 11 Newton meter per radian. Because polar moment of inertia will be calculated like this: pi into bracket start d1 square d to the power 4 minus d2 d1 to the power 4 minus d1 d2 d1 to the power 4 minus d2 to the power 4 bracket close open 32, where d1 d2 is a outer inner diameter. Now first torsion natural frequency is coming as 322.621 radian per second, and in hertz it is coming 51.4 hertz after dividing omega by 2 pi. And this is the mode shape of the first torsional natural frequency. This is second torsional natural frequency, which is coming as 558.796 radian per second, and in hertz 88.9 hertz. And this is mode shape for the second torsion natural frequency. So with this, hope you understood how torsion natural frequency for the hollow shaft is calculated using the Holzer methods. Thank you for watching.